What if the universe didn't begin with the Big Bang? What if, instead, it was just the latest chapter in a much older story, one that stretches far beyond the limits of time itself? Recently, the James Webb Space Telescope captured images so strange, so impossible, that they forced scientists to ask a question that was once unthinkable. Did galaxies exist before the Big Bang? Because what Webb has just found challenges everything we thought we knew about how the cosmos began. When Webb peered deeper into space than ever before, it discovered 15 mysterious galaxies, tiny points of light from a time when, according to our current understanding, galaxies shouldn't even exist. Their light has been traveling for nearly 13.6 billion years. That puts them at the very edge of the observable universe, so close to the beginning of time that technically they shouldn't have had the chance to form at all. And yet there they are, fully formed, massive, structured, and bright. These galaxies don't just break the rules, they rewrite them. To understand how shocking this discovery is, let's rewind. The Big Bang Theory tells us that the universe began 13.8 billion years ago as a singularity, a point of infinite density that suddenly expanded, giving birth to space, time, and matter. In those first chaotic moments, the universe was hot, dense, and blindingly bright. Then it cooled, forming hydrogen and helium atoms, leading to the first stars and galaxies hundreds of millions of years later. At least that's the story we've believed for decades. But the galaxies Webb is finding appear to have existed just 250 million years after the Big Bang, too soon for physics to allow. They are far more massive than any simulation predicts. Some contain as many stars as the Milky Way, even though our galaxy took billions of years to grow that large. So how could these cosmic giants have formed almost instantly after creation? Or, as some scientists are now daring to ask, did they form before it? When astronomers analyzed the light from these galaxies, they found something peculiar. Their redshifts, the stretching of light due to cosmic expansion, were far higher than expected, placing them deep within the universe's infancy. But what made them so baffling wasn't just how far away they were, it was how mature they looked. Their stars weren't newborns, they appeared old, enriched with heavy elements that could only exist after multiple generations of star formation. That means they weren't just forming for the first time, they had already been through cycles of birth and death, suggesting that some process was happening long before the supposed beginning of time. The James Webb Telescope was designed to see back to the first light, to the moment when the cosmic dark ages ended. Instead, it seems to have found light that shouldn't exist at all. The implications are staggering. One possibility is that our model of the early universe is incomplete. Maybe galaxies could form faster and earlier than our equations predict. Maybe gas and dust condensed into stars far more efficiently under extreme conditions. But the sheer number and mass of these galaxies make that explanation difficult. It's like finding a skyscraper in the middle of a desert and realizing it was built before the desert even existed. Another, far more radical theory is that these galaxies didn't form in our universe. They formed before it. You see, not all scientists believe the Big Bang Theory was truly the beginning. Some cosmologists argue that our universe may have emerged from the collapse of a previous one, a process known as conformal cyclic cosmology proposed by Nobel laureate Roger Penrose. In this view, time never really starts or ends. Instead, each universe expands, fades, and gives birth to the next in an endless loop. If that's true, then the light Webb is seeing could be the last echo of the universe that came before ours, a bridge between cycles of cosmic existence. In other words, those 15 galaxies might not just be ancient. They could be relics from a universe that died and was reborn. But let's not get ahead of ourselves. Before rewriting all of physics, astronomers are taking a closer look. Webb's instruments are so sensitive that they can detect even the faintest flickers of infrared light. That makes it possible that some of these galaxies are actually something else, like quasars powered by supermassive black holes that emit intense radiation. Yet even that explanation opens another mystery. How could black holes so massive exist so early in cosmic history? Every possible answer seems to raise more questions. One team of researchers at the University of Edinburgh tried simulating how such massive galaxies could form so quickly after the Big Bang. The result? The math didn't add up. The simulations broke. The models simply couldn't produce galaxies that large, that luminous, that early. This left scientists with two possibilities. Either the James Webb Telescope is somehow misreading the light, or the universe is hiding a secret about its origins. And it's not the first time we've seen hints of this. Before Webb, the Hubble Space Telescope detected faint red-shifted galaxies that also appeared too early. But Hubble's instruments weren't powerful enough to confirm them. Webb, however, has infrared eyes that can pierce through cosmic dust and see much farther back. Its observations confirmed that those early detections were real, and that there were far more of them than anyone expected. At this point, we're left with an uncomfortable but fascinating question. What came before the Big Bang? Some physicists have long suspected that the Big Bang might not have been the beginning, but a transition, a bounce from a previous universe. In these models, space and time could collapse inward under gravity, creating a dense state that expands again. Instead of one universe with a clear start, reality becomes a chain of universes, each giving birth to the next. And here's where things get really intriguing. The energy from a collapsing universe could seed the next one with the materials needed to form galaxies almost instantly. If true, the 15 galaxies Webb has seen could be survivors, remnants from a cycle that ended long before ours began. Imagine it. Galaxies born in an earlier cosmos, carried through the fire of rebirth, now shining faintly across eternity, whispering that the universe is older than we ever imagined. But there's another, even bolder idea on the table, one that ties Einstein's relativity with modern quantum theory. It's called the multiverse hypothesis. According to this idea, our universe is just one bubble in an endless cosmic foam, each bubble representing a separate universe with its own physical laws. Sometimes these universes might collide or interact, creating brief bridges through which energy or light could pass. If that ever happened near the edge of our own universe, it could explain why Webb is detecting galaxies that seem to exist outside our timeline. They could belong to a neighboring universe, light bleeding through from another reality. That's not fantasy. Mathematically, it's consistent with some versions of cosmic inflation theory, which describes how space expanded faster than light, fractions of a second after the Big Bang. Some physicists believe that process could have spawned countless pocket universes, each evolving on its own. Could Webb, in its incredible sensitivity, be catching glimpses of those other worlds? It's a possibility too profound to ignore. But even if we stay within the bounds of our own universe, the implications are staggering. If galaxies truly existed so soon, or before the Big Bang, it means the forces that shape the cosmos operate on scales and speeds we don't yet understand. Gravity, dark matter, and dark energy might behave differently in the extreme conditions of the early universe. The laws of physics themselves may not be universal. They may evolve, just like everything else. And that brings us to a sobering truth. Every time humanity builds a more powerful eye on the cosmos, we find something that contradicts what we thought we knew. Hubble showed us that the universe is expanding. Webb is showing us that its history might be more complicated than expansion alone, that perhaps time itself is layered, folded, or cyclical. So what happens next? Over the coming years, astronomers will use Webb spectrometers to study the chemical fingerprints of these galaxies. If they truly contain heavy elements like carbon, oxygen, and iron, it will confirm that they've undergone multiple generations of star formation, far too many for the age of our universe. If that happens, cosmology will face its biggest shakeup since Einstein. It evolved out of something else. Think about that for a moment. The Big Bang has always been our origin story, the beginning of everything. But what if it was just the latest page in an endless cosmic saga? What if time has no true beginning, only transformations? Maybe the universe isn't a straight line, but a circle. And every time it ends, it begins again. The 15 galaxies that Webb found might be more than just distant lights. They could be the footprints of eternity itself. Evidence that creation and destruction are two sides of the same cosmic coin. For now, Webb continues to stare into the past, capturing photons that have been traveling since before the dawn of time. Each new image adds another piece to a puzzle that may never be fully solved. But perhaps that's the beauty of it, the mystery that drives us forward. Because the farther we look into space, the more we realize that the universe isn't just out there, it's also a reflection of us. Curious, searching, and never content with simple answers. So what do you think? Are these galaxies proof that something existed before the Big Bang? Are they remnants of a previous universe? Or clues that our cosmos is far stranger and older than we ever imagined? Share your thoughts in the comments below, and don't forget to subscribe to Cosmo Life for more journeys to the edge of existence. Because every time we look deeper into the universe, we're reminded that the story of creation may not have a beginning, only an endless horizon.